Okay, if you missed the 10-4 determinant and inverse section for Algebra 2 Part 2, what we did is we learned how to find what's called the determinant of a 2 by 2 matrix. Now you can find the determinant of any square matrix, and there's a process to doing that, but we're going to restrict and just do the 2 by 2 matrices. Okay, when we do that, what we do is we take the product of the diagonals and we subtract them. We're always going to start in the first row, first column, but that diagonal, A times D, the numbers that are in those positions, we take that product and we're going to subtract this product, whatever values are in that position. So we're going to subtract those two products. So when I look at this first example, when I find the determinant of this 2 by 2, I'm going to take 9 times negative 5. Okay, that's a negative 45. And I'm going to subtract, it's always subtraction, and I want to subtract this product. So this would be 3 times 4. So I'm taking negative 45 and I'm subtracting 12. Okay, remember when we subtract positive and negative values, we have to do leave, change, change. So this would be a negative 57. Okay, for letter B, I'm going to take this diagonal, 6 times negative 4, would be a negative 24. And I'm going to subtract 1 times negative 2. I do leave, change, change, and I get a negative 22. So my determinant value is negative 22. Okay, that's very simple. That's how you find the determinant of a 2 by 2 matrix. Now we go on and talk about what the identity matrix is. We have identities in math, like the additive identity. Back in Algebra 1, we talked about what the additive identity was. It's what can I add to 5 so that it would keep its identity. Well, you would say 0. 0 is the additive identity. When I'm multiplying, what can I multiply a number by so that it keeps its identity? Well, you would say 1. 1 is the multiplicative identity. So we've talked about identities before. Well, we have an identity matrix, and the identity matrix is 1, 0, 0, 1. So you have 1s in that diagonal. Everything else is 0 in the matrix. And what we say is matrices are inverses of each other if when you multiply them together, the result is that identity matrix. Okay, so if I take two 2 by 2 matrices together and I multiply them together, if that identity matrix is a result, then we would say that those two matrices are inverses of each other. Okay, so here's how you find the inverse of a 2 by 2 matrix. You're going to take and you're going to first determine what the determinant is. You're going to find the determinant value, and we put 1 over the determinant value. Okay, and then we're going to flip these two, the positions of these two. We're going to flip those, and we're going to change the signs.
Did I leave something in here?
Did you?
I don't know.
I didn't find anything. So the values that are in these two positions, they switch. So the D comes up here, the A goes down there, and then these two stay in the same place, but they just change the signs of those. And then we're going to do the scalar multiplication there. So here's what I mean. For finding the inverse for A, I first have to find the determinant. Oh, there we go. Wrong button. I'm going to start by finding the determinant. So I've got negative 15, and I'm going to subtract negative 16. Okay, so negative 15 minus a negative 16. I do leave, change, change. It gives me a value of 1. Okay, so I'll move over here. So I say 1 over that determinant value, which is just 1 over 1. And then I switch the position of those two values. Let me erase this for you so you can see it. I switch the position of those two, so negative 3 comes here, 5 goes there. And I change the signs of those two. So this becomes positive 2, this becomes negative 8. And then you want to do this multiplication. So 1 over 1, that's just 1. So you're going to take every number in the matrix times 1. So that's just going to say negative 3, 2, negative 8, 5. This matrix right here is the inverse of this one. And what that means is if I were to take this original matrix times this, I would get that identity matrix. I would get a 1, a 0, a 0, and a 1. Okay, let's try B. Right? Find the determinant first, so that would be negative 10 minus a negative 9. Do leave, change, change. You get negative 1. So you say 1 over that determinant value. You change the places of those two, so it's going to be negative 1 and 10. And then these change signs, so this would be positive 3, and that would be negative 3. Okay, now you just do the multiplication. This is scalar multiplication. 1 over a negative 1, that's a negative 1, right? So every number inside the matrix gets taken times negative 1. So I can get a positive 1, a negative 3, a positive 3, and a negative 10. Okay, these two matrices are inverses of each other. And the symbol for an inverse, we've seen this before. If this is matrix A, then the inverse of it has a little negative 1 by it. Okay, just to show you, okay, so here's the original matrix, 10, negative 3, 3, negative 1. We just found its inverse. We're saying its inverse is 1, negative 3, 3, negative 10. Okay, so what that means is when I multiply, and you don't have to do this, but just to show you, if I multiply these two matrices together, so you do a row times a column. This would be 10 plus a negative 9, that'd be a 1. Do first row, second column, this would be negative 30 plus 30. Move to the second row, first column, 3 plus a negative 3. Second row, second column, this would be negative 9 plus 10. You see that the result, the product of those two inverses is your identity matrix. And that's what we're finding. So they're going to give you a matrix. They're going to ask what's its inverse. Okay? That's how you find the determinant and the inverse.